Hi everyone! Today we are starting our new unit on atoms. This is unit 2. We've just finished states of matter and we're now going to look at how atoms are structured and how they can fit on the periodic table, how they can react, the differences in the atoms, and what happens when we change different parts of the atom. So the first thing we're going to learn about is what is an element. We're going to label different parts of the atom. We're going to learn about the periodic table, what periods and groups are, how to draw a Bohr model of an atom, and then we're going to practice. All right, so our topic today is structure of atoms. We're going to obtain, evaluate, and communicate information from the periodic table to explain the properties of elements. So the first thing we want to do is develop and use models to compare and contrast the structure of atoms, ions, and isotopes. Today what we're going to do is we're going to focus just on plain old neutral atoms. So the first thing I want you to do when you get to this slide is I want you to click right here. You'll notice there is a play button. Play this first. It's going to tell you all about the element. It's going to tell you that an element can't be broken down into simpler substances by heating or causing it to react. So an element is one substance that cannot be broken down. The smallest unit of that element is an atom. And atoms are made of three things: protons, neutral neutrons, and electrons. Remember, protons start with a P, they are positive. So the pure sample of an element may contain many atoms of the same type, but all elements have unique properties. It's the atoms of an element that determine the property. So here we've got three different parts. The first thing you are going to do is you are going to click on this video right here and watch that first. Okay, and then we're going to talk about these things. There's going to be something for you to drag here, so be sure you do that. Our positive protons are red. Our neutral, plain, no charge things in the middle are neutrons. And then on the outside, the negative blue ones are electrons. So these protons have a weight of 1 AMU. That is a unit of measurement. But let's just say their unit is very, very small, but we want to give them a weight. So we're going to say these two weigh the same thing. The protons weigh 1, the neutrons weigh 1. The electrons weigh nothing. The reason for that is they are spinning at such a high rate around the outside. If they had weight, it'd be like an unbalanced hula hoop. So we have to have them with no weight so that they can orbit perfectly and transfer easily. So the inside protons have a weight of 1, neutrons have a weight of 1, electrons have a weight of 0. Read the instructions on the side of your digital notebook to find out what I want you to put here. I'm going to need you to put the charge, the mass, and one other thing. Be sure to look on the outside. Okay, the first thing I want you to do is click this listen button and play this sound. I'm going to tell you exactly how we find these. So on the periodic table, you're going to see elements that look like this, 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 and this. So we have helium right here. The top number, which notice there's always two numbers. The top number, right, in this case, is smaller. The smaller number on the periodic table is always going to be your atomic number. Not necessarily the one that's located on top, but the smaller number is your atomic number. This tells you how many protons you have. Okay, so how do we find the number of protons? By looking at our atomic number. Okay, so the atomic number is like the DNA of the element. Just like your DNA tells who you are, this tells who the element is. We always know that this atomic number tells us how many protons. So helium always has 2 protons. All right, the symbol tells us what it is. It's like a nickname. So He stands for helium. And then our atomic mass is right here. It's 4. The atomic mass is always going to be larger than your atomic number because this includes the atomic number plus the neutrons. This one will always be larger. So if we want to find the atomic number, all we have to do is look at the periodic table, and it's going to equal our protons. It's also going to equal our electrons. The reason for that is in a neutral atom, remember, protons are positive, electrons are negative. If we're neutral, we want them to be equal. We want our positives to equal our negatives. So our protons and our atomic number are the same. Also, it's the same as our electrons. So right here for helium, helium has 2 protons, it's got an atomic number 2, and it's got 2 electrons. So right here for the electrons, you're going to tell me that you find that by looking at the atomic number because it's the same as the protons. How do we find protons? By looking at the atomic number. So you'll notice right here for carbon, our atomic number is 6, our protons are 6, and our electrons are 6. Now let's look at finding the neutrons. I told you that the atomic mass is the atomic number plus the neutrons. So if we want to find neutrons, we can take this and subtract our atomic number. So to find our neutrons, we're going to take our atomic mass. In helium's case, it's 4. We are going to take our atomic number, which is 2, okay, and subtract those. So our atomic mass, 4 minus 2, gives us 2 neutrons. So right here, to find our neutrons, we take atomic mass minus atomic number. Another way you could do it is say your atomic number plus your neutrons gives you atomic mass. So right here, to find our neutrons, we need to have the atomic mass minus the atomic number. So look here, we've got our atomic number and our atomic mass. So if we take 12 minus our atomic number, it gives us our neutrons, 6. So let's try this with carbon. Carbon has an atomic number 6, which means it's got 6 protons and 6 electrons. It's got an atomic mass of 12. So if I want to find my neutrons, I'm going to take my mass, 12, minus my atomic number, 6, and I'm going to get 6. What about neon? Okay, neon has 10 protons, because its atomic number is 10 electrons, because the atomic number is 10, but its mass is 20. So remember, to find our neutrons, we have to take atomic mass minus atomic number. So 20 minus 10 is 10. So your atomic number for neon, 10. Your atomic mass, 20. 20 minus our protons, which we know protons is the same as atomic number. So 20 minus 10 gives us 10. And we know electrons is the same as protons, so that would be 10. Sodium. Sodium has an atomic number of 11. Its atomic mass is 23, because we can round up, so 23. So we know that our protons is the same as our atomic number, so I'm going to look right here, I'm going to say 11 protons. So you should have 23, 11, and we've got 11 protons. So 23 minus 11 is 12. So we have 12 neutrons. And remember, our electrons is going to be the same as our protons, so you would have an 11 right here. Sorry, that's for sodium. So what I want you to do when you finish that is listen to this little icon down at the bottom to make sure you got them all correct.